Okay, so let's look at our review here, or our warm-up, So on the warm-up, all we're doing is practicing shading in these angles because sometimes I think people miss it based off of just not knowing which angle we're talking about. So number one says to shade an angle ABC. Now remember when we name an angle, the order of the letters matters, and remember that the middle letter is always the vertex letter. It's the one that's at the corner of the angle. So we're talking about angle ABC. We start at A, we go to B, that's going to be the middle of the angle, and then we go to C. So we go from A to B to C, and so that means we're talking about this angle right here. So when I say angle ABC, we'll be talking about that angle right there. Okay, next one, BCE. So we go to B, then to C, then to E like this. So it's this angle right here. Okay, the next one, it goes B to E, then to C. So it's talking about this angle right here. Okay, next one is ADB. So we start at A, we go to D, then we run to B. It's talking about this angle right here. The next one, AED. So AED is this angle right here. And then on this last one, BCD is talking about this angle right here. So today what we're going to do is we're going to kind of practice the stuff that we've been doing for the last week. Going over it, we're going to review these properties and do a few problems with it. So the first thing we're going to do here is the 4 properties of parallelograms that we've done even last week. So remember the first property here is that opposite sides are congruent. In any parallelogram, opposite sides are congruent. So if this side is 4 units, this side is 4 units, this side is 6, this side would be 6. All right, second property is opposite angles are congruent. Okay, opposite angles are congruent. So for instance, if angle G is 100 degrees, angle J is 100 degrees because those are what we consider opposite angles. Opposite angles are congruent. Okay, third one. Somebody remember what this one says? Okay, good. Yep. So consecutive angles are supplementary. Consecutive angles are supplementary. And yeah, supplementary means they add up to 180. Consecutive means like right next to each other. So like in this case, G and F would be an example. So like if angle F is 80 degrees, angle G would be 100 degrees. Okay, because these two are always going to add up to 180. Any parallelogram. Because that's like an example of same side interior angles, okay, of parallel lines. So these two are always going to add up to 180. These two would add up to 180. These two would add up to 180. These two would add up to 180. Okay, and then this last one, does anybody remember what this last one said? The diagonals. Good. The diagonals bisect each other. The diagonals bisect each other. Remember, bisect means to cut exactly in half. So what that means is these cut each other in half. So if this piece is 3, then this piece right here would be 3. Always splits them exactly in half. Okay, so those are the 4 main properties of parallelograms. Then we got into talking about rectangles, which is a type of parallelogram, but it's got something more specific about it. So this first one right here is kind of like the defining feature of a rectangle. So what makes a rectangle a rectangle?
490 degrees.
Good. It's got 4 90-degree angles. Like 90, 90, 90, 90. That's what it means to be a rectangle. It's got 4 90-degree angles. Okay, one property of rectangles that we talked about is that the diagonals are congruent. Diagonals are congruent, which is different than just a generic parallelogram, because like up here on this parallelogram, this diagonal and this diagonal would be 2 different lengths. On a rectangle, this diagonal GJ is always going to be congruent to like this diagonal HK. Diagonals are always equal, so like if that's 30 feet, this one would be 30 feet. Okay, yesterday we talked about rhombuses, rhombi. So what is the defining feature of a rhombus?
It has 4 equal sides.
Good. 4 equal sides or 4 congruent sides? Exactly. So a rhombus has 4 equal sides. So if this side is 9, this side is 9, this side is 9, this side is 9. Okay, now 2 properties of rhombus that we talked about yesterday. First thing is that the diagonals are perpendicular. Diagonals are perpendicular. What does perpendicular mean?
They cross.
They cross to make a 90-degree angle. So inside of here, in any rhombus where these 2 diagonals meet up, it's always going to make 90 degrees in here. Okay, which means all of these angles are 90. Every single one of those angles in the middle there is going to be 90. We'll use that fact a couple times today at least. And then the second property of a rhombus we talked about yesterday is that the diagonals not only are perpendicular, but the diagonals, bisect the angles. Diagonals bisect the angles. Again, bisect means to cut exactly in half. So as an example of that, if this angle is 30, then this angle right here is 30, which would mean that this is 30 and this is 30. So in any rhombus, like these 2 angles and these 2 angles, all 4 of those are going to be equal, and then this one, this one, this one, and this one are always all going to be equal. Okay, so that's a lot of little properties we've talked about this week. We haven't talked about kites or trapezoids. That's on here, but we'll talk about that on Monday. So let's go ahead and flip over to the back, and let's work out some problems related to those properties. So on number 1, this is a parallelogram. So how big is angle R?
135.
Good, it's 135. Because these 2 angles are what we would consider opposite angles, and so opposite angles are congruent in a parallelogram. Okay, how big would that angle be on number 2? 110, because these add up to 180. Those are what we would consider consecutive angles. Consecutive angles add up to 180. Okay, and the next one, how long would this side right here be? 11. How long would this side be?
9.
It would be 9, same length as this side. Okay, number 7, this is a rhombus, and it says we're looking for angle SQR. So SQR is this angle right here. Now, since this is a rhombus, we know that the diagonals bisect the angles. So if that angle is 22, this angle right here is 22, which means this one's 22, which means this one's 22. Which this 22 is the one that I'm interested in. It's going to help me out here. Now, also, since this is a rhombus, what do I know about these angles in here?
90.
They're all 90. So now I'm going to use that to help me find this angle right here that I'm looking for. Because now if you think about it, just forget about the rhombus and just think about this whole triangle right there. Forget about the rest of it. In a triangle, what do these three angles add up to? 180. So I'm going to do 180 minus 90 minus 22, and whatever's left is going to give me this. Okay, good. So 180 minus 90 minus 22, yes, is 68. Okay, number 8, it's asking for angle NLM. So NLM is this angle right here. All right, and so since that one's 55, that one's 55, this one's 55, this one's 55. So that one's easy. Okay, on this one, first of all, how big is angle 2?
90.
Is 90. Right? You know that because angle 2 is right here. In a rhombus, these angles in the middle, where the diagonals meet up, is 90. Now, this angle's 90, this angle's 20. How am I going to find angle 1? Good. So 180 minus 90 minus 20. What does that give you?
70.
Good. So angle 1 is 70, which actually means angle 3 is 70, and angle 4 is 70. All right, next one. Okay, so this is a parallelogram. In a parallelogram, what do I know about these two angles right here? They add up to 180, exactly. So on this one, what I'm going to do is I'm going to go 4x plus 5 plus 3x equals 180. So we'll combine like terms 4x and 3x makes 7x, still with the plus 5 equals 180, minus 5, 7x equals 175 divided by 7, x equals 25. Now this asks for angle N, so angle N's up here, I don't know nothing about that, but I do know in a parallelogram that these opposite angles are equal, so if I can find the measurement of angle L, I'll know the measurement of angle N since they're the same. So I'm going to plug in 25 right here. What's 3 times 25?
85.
Is 75. Okay, the next one in this parallelogram, all right, opposite sides are congruent. So I'm going to set these equal and solve for x. So I'm going to go 7 plus 3x equals 43. So I'm going to subtract 7 on both sides. That's going to give me 3x equals 36. Divided by 3, and x equals 12. Okay, the last one is a rectangle, and it says angle 1 is 50. So angle 1 is 50. Now, since this is a rectangle, what do I know about this whole angle P right here?
It's the opposite of the other side.
Okay, we'll get to that in a second, but yeah, this whole angle together is a 90-degree angle. Remember, in a rectangle, the angles are always 90. So this angle is 50. How big is this angle going to be if this whole thing is 90? It's got to be 40 because 50 plus 40 is 90. Okay, now since this is a rectangle, this is like symmetric. So like this angle and this angle are congruent since this side and this side are congruent. So angle 3 is 40. So how big is angle 5? 50. Okay. Now, angle 3 and angle 6 are like alternate interior. Those are congruent. So this is going to be 40. And this one's going to be 50, just like angle 4, which means angle 5 is 40. Now let's think about this. So let's find this one angle that's blank right here. So again, the 3 angles in the triangle add up to what? 180. So if this one's 40 and this one's 40, what does this one have to be for all 3 of these add up to 180? It's 100. Because 100 plus 40 plus 40 is 180. So that angle is 100, which means angle 8 is 100. Why? Good, because they're vertical angles. Good. And then what do I know about these two next to each other right here?
They add up to 180.
They add up to 180. Good. So if this one's 100, how big is angle 10? It's got to be 80, which means angle 9 is 80 because of vertical angles.